Hello, hello, hello. Am I audible? Hello.
Hi, sir. Good evening.
Just wait. Hello. Yeah. So should we start now?
Yes, sir.
So as you know, like today topic is on rheology. So I'll I'll take just few minutes to explain you. So what is rheology actually, right? So and why it is important. All right. So as you know, in polymer, right? So we used to measure many rheological properties like we used to measure MFI of the mass and we used to measure viscosity. All these things are related to the rheology of the polymer, right? So why rheology, right? Why we require rheology? So rheology has a root, like many of the scientific word has a root to the Greek, right? Like rheo means like flow and logos means study. So mostly rheological property of any polymer that we are measuring. So we are what we are doing, we are just measuring its flow behavior, right? So as you know, like from low viscosity polymer, uh, so your slide is not visible, right? So it is visible to all slide.
Yeah, it is visible to me.
Yeah. So as you know, like rheology deals with the flow behavior of polymer, right? So it is mostly while we are measuring the flow of any polymer, so it is not only flow, we are measuring it, we can easily measure the flow by MFI also, but when we are measuring any kind of flow behavior, so how the material behave under certain stress, right? Under certain strain, how it will behave. So that flow behavior is known as rheology, right? Rheo means flow and logy means study, right? Logos. So that from that word rheology has come from, right? So in your mind, you might be thinking, so what is the difference then? So uh, like why you require rheology to be measured, right? So I will give you very few example like flow natures of any polymer or like any polymeric materials, right? So like flow nature of how, so how they will flow, like either it would be toothpaste. So everybody's in toothpaste, right? Praveen?
Yes, sir. We
Yeah.
have seen.
So for toothpaste, when you are what you are doing, you have to apply certain stress to, right, to get it out from the tube, right? Right. When you are using toothpaste. For that material requires some certain amount of yield stress. Like you have to like what you have to apply certain amount of stress to get that metal out of the tube, right? So that is the flow nature of that material. What you are doing, you are applying some stresses and you are seeing that your material can flow, right? That is the example, right? So flow nature, how they will flow like toothpaste, water, or oils. Like these are three examples. If it is a water or oil, it is mostly Newtonian behavior. If it is like a toothpaste, it is mostly like a Bingham plastic. Like that means it requires certain amount of yield stress to flow, right? Then what is the viscosity and how is the viscosity of that material? Are there consistent viscosities there, right? Like water, curd, or honey? How what are means how the behavior, whether it is like water or curd or honey, it has some viscosity, but it is mostly Newtonian like honey, right? What are the processing methods, right? When you are measuring the viscosity, so you have to look into the processing method. As polymer, we have different processes like injection molding, blow molding, extrusion, right? So the different processes has different shear rate, right? According to that, also we have to decide the rheology behavior of any polymer and nature of the material. Last term, there are four important properties. What is the flow nature, right? What is the viscosity of that particular material? And what is the processing method for that particular material, and what is the nature of material, either it is elastic material, the melt is mostly behaving like elastic, or it is viscous, right, like viscous fluid, or both, right? As you can see in the in this as you can see, it is mostly like Newtonian fluid, right? You can see that. So this is mostly Newtonian liquid and this is mostly viscous liquid, right? So depending upon the nature of the material that we are using, we have to determine its flow behavior, right? So different polymer has different flow behavior that we'll discuss later, right? So rheology is the science that studies the deformation and flow of material in liquid, melt, or solid, right? Mostly in the forms of material elasticity or in viscosity, right? So these are the rheology terms. What it does is we have to study the material behavior, right, in the form of liquid, melt, or solid. But mostly solid rheology we don't do. Either it will be liquid state, complete liquid, or it is a molten state, like polymers, right?
So, rheology is meant for only set thermoset plastic or blow mold certain things or injection molding or any material. This rheology concept is applicable.
That I will tell you. Wait, I'll go to that. So I'm just explaining what is basic rheology is, right? So elasticity means there is the ability of material to store and deform energy. These are the basic concept when you are using rheology. Rheology itself is very tricky, right? So you have to always apply your mind to understand any rheological concept, right? So for that, you require like certain amount of expertise in the field of rheology, right? So basic what we are doing, as Karnalati said, like uh, how is the what is your question? Pardon me. Hello.
Rheology is applicable for thermoset or thermoplastic, or is it for injection molding and like blow molding or any particular process, or it's for all the injection
No.
molding, all the plastic process?
Rheology is applicable to the all the materials. Let it be plastic, honey, paste, sugar, anything that can flow, right? Rheology is a concept. Overall, it is applicable in the food also, right? In the chemical industry also, in the polymer industry also. But different segment has different types of rheology concept, right? We're getting my point,
Yes, sir.
right? So when you tell about polymer, basically, as your question is on polymer, yes, it is applicable. There is a difference. Thermoset rheology is different and thermoplastic rheology is different, right? Also, in thermoplastics, there are different steps, right? So when you do go for different processes like injection, extrusion, blow, that all these three process that I have told you earlier, these three process has different types of rheology, right? This process shows different processes, different rheology. Like injection molding has a higher shear rate, right? So the rheological concept in injection molding is different. The rheological concept in is blow molding is different, and the rheological concept in extrusion is different, right? But how can you the main point is what? One is a viscosity data that you are getting, right? What you are getting is a viscosity data, right? So, but the nature of rheology not only deals with the viscosity data, but it also deals with the nature of curve, the nature of graph that will be obtained from this, right? So, what is the nature of graph? Whether it is a polymer is mostly the that like polymer is shear thinning behavior. So, most of the polymer when we apply shear, it started to lose its viscosity, right? Right. So it is I can give you a bit good example. As Probin is working in MFI. Probin, you have worked on MFI, right? Hello.
Yes, I have worked on MFI.
So just tell me, have you had the concept of when you are applying load, right? Certain
Yeah,
material has three type of load. Like you are applying we are doing MFI with 2.16 kg. You are doing it 5 kg. You are also doing the MFI with 10 kg, right?
3.8 kg, 1.25 kg.
Yes. So why it is there? Can you why can you guess why it is there? All this load is there?
Actually, based on different material, different load and temperature are applied. Like if we are
Okay.
doing on any MFI of nylon 6, polyamide 6 or double 6. So
Yes.
polyamide 6 will be tested on a 235, 2.16 kg load. And if we are testing any ABS material, MFI, then we have to apply 220 degrees Celsius temperature and 10 degree load, 10 kg load.
Yes. Because that particular material, if you go above 220, material will degrade. But to flow that particular material, you require certain amount of stress to be applied. That stress should cause
Hello.
more. Yes.
Am I
Yeah,
audible?
problem. Yeah, you are
Yeah.
audible. Tell
Okay.
me. Now, what I'm saying is why they have designed this such thing is for particular material they have designed a particular load because that material has that much threshold stress value that load will provide, right? So if you go to higher temperature, your question might be arising, sir, why can't we go up to 250? But your metal will be degraded at 250. So what they have done, they have keep the temperature low, but they have applied a threshold stress value. That stress value will impart flow on your proper flow property on your polymer, right? So you will at that particular temperature and that particular pressure, you will get a polymer to flow. So that's why this all this load has segment has been designed because if you want your metal to flow, so you will increase your load. You will not increase your temperature because by increasing the temperature, your material might get degrade, right? So that's why load will be increasing. So load, अगर आपके load कोई भी, if you are increasing the load, the more amount of stress will be generated on the material, and your material will started to flow, right? So that is the concept behind the flow behavior of any polymer, right? That you are like that you are dealing with your daily lab basis, right? So So, the flow properties of any materials, right, mostly has a viscosity range, right, and it has some kind of modulus, shear rate, and shear strain, right. So if you want to only measure the viscosity flow property of material in the case of viscosity, there are four methods to measure the viscosity, right? One is Brookfield viscometer, one is glass viscometer, one is Ford cup viscometer, and one is falling ball viscometer. These are the viscometry methods to measure the flow behavior of any material, right? It can be paints, it can be any emulsion form, right? It can be polymer solution, right? To measure all these things, you require, these are the viscometry method, and you also have the rheometry method. So why people prefer rheometry method over viscometry method? Because the rheometry method provide better idea of nature of the graph, rheology graph. Viscometry method, you will get only a single value, right? But in rheology, you will get a whole range of graph from low shear range to high shear range, where you can easily see how your material behaves in general shearing condition, because when you are putting your polymer into any kind of process like injection molding and all, in that process the your material will be getting more shear, right? So that rheology, that data we can only analyze through different types of rheometer, right? To that shearing range and how material flow will, how the flow of your material will be, right? Because only what MFI does is the MFI is going to give you the single point data, right? What is a single point data? MFI will going to give you a value. That particular value you are going to use it. Yes, my MFI value is this and my MFI value is that, but that does not has any scientific significance onto the flow behavior of polymer. So when you are talking about the flow behavior polymer, you have to go for rheological data, right? Rheology data means what? You are just analyzing your polymeric material and nature of your polymeric material through different types of rheometers, right? Like cone and plate rheometer, parallel plate rheometer, cone and cup rheometer, capillary rheometer. These are the different type of rheometer, right? Am I audible? Hello. Okay. So these are the viscometry method, right? So I think you have you have some familiar things. So I think Provin has told me earlier that he has done some viscosity. Provin, are you there? Or you have lost your connection? Hello. Am I audible to all? Hello. Hello.
Yes, sir.
So you are familiar with viscosity data? You have done viscometry.
No, sir.
Provin, you
Viscosity
have
or
done?
viscosity number?
Yes, yes, viscosity number and all, Brookfield and all, and this capillary viscometry you have done.
Yeah, I have tested.
Right. So why I'm telling out viscosity data? Because some of the polymer you require viscosity data as well as rheology data, right? So what happens in viscosity data? You are preparing some low concentration solution. You are flowing through two meniscus, right? That is 2 point reference point. You are flowing it and you're making. You are just measuring its time. Also, you are measuring the viscosity, right? Again, by measuring the viscosity, what you are measuring, you have to measure the different type of viscosity, such as relative viscosity, specific viscosity, intrinsic viscosity. These are the viscosity numbers that you want to measure to understand what is the flow behavior and flow properties of polymer. If your molecular weight of your polymer is high, then viscosity number will be higher, right? If your molecular weight of your polymer is low, then your viscosity number will be lower. So these are the viscometer glass. This is known as a glass viscometer techniques. Whereas in Brookfield viscometer, what it does, we prepare a solution. We have different types of spindle, right? There are different spindle to it, attached to it. You can attach different spindle and you can check the viscosity. And you have to what you have to do. You have to just uh, describe the spindle number, right? So when you have to find out the actual spindle and you have to test it and you have to mention that this spindle number by this spindle number at this RPM, I've got a viscosity of this CPS. CPS is nothing but viscosity in centipoise, right? So these are the old method for measuring like Brookfield viscometer, glass viscometer. These are methods, but still it is running in the industry. These now they have like previously it was measured by manual things like you have to do manual calculation and all. Now the machine has come, right? Provin, or you are doing it manually.
No, we are having automatic machine.
So
We are having one
which
more manual machine previously we are having, but now we have discarded.
okay, so automatic machine, what machine you have? Right?
16
Okay. So that it will provide all the data, right? Viscosity data,
relative
efflux type of
viscosity. Yeah.
yes. Because that's why I'm saying when we are talking about measurements, it is better, always better to go for a machine measurement because machine measurement you do not associate it with any kind of human error because anyway machine will analyze all the data, right? You have to only give the good amount of input to analyze the data, right? So it is always to be do a measurement of any substance and thing that you are commercially use or you are going to use for any specific applications. So it is always it is always good to be measuring on automatic machine data, right? It is because it does not involve any kind of human error. Yes. Somewhat that you also you have Brookfield viscometer. Then in from Brookfield viscometer, you can also calculate the viscosity as per the spindle number, and you have to mention the spindle number. So this spindle number at this RPM, this is the viscosity of that, right? Also, there are other methods by you also have to calculate. If you want to calculate, then you can calculate through pot cup methods, right? Pot cup method is nothing but the you have to pour the cup up to like its brim, then you have to calculate the viscosity, calculate the flow time that your cup has been like getting empty, right? That flow time you have, that they have different Ford cup chart. That flow time you have to see this flow time as this viscosity number that you have to match, right? So this is a flow Ford cup method, and which a falling ball viscometer means you are just you are just dropping a ball at certain height and you are just measuring so how much time it will take to reach to the bottom of that container that filled with your liquid that to be measured. So these are the techniques for measuring the viscosity of any materials, right? I'm not talking about monomer. It can be polymer solutions, it can be emulsion, it can be other pharmaceuticals emulsions and all these methods are used to determine the viscosity, right? So
Sir,
Yes,
why,
sir.
in previous
sorry,
slide, the first
yeah.
quadrant, first, no, previous slide. Here it is mentioned viscosity measurement as a function of torque.
Hmm.
How it is, sir?
Look, the machine has certain torque, right? It will rotate the spindle, RPM. If the RPM will be there, so it will generate torque on the motor,
Okay,
right? So whatever it is showing that, do not measure the measurement when under 10% torque will. So whatever the measurement will come before below 10%, that will be not a accurate measurement, right? So if a motor will rotating, it should have a torque. The better the torque, you will get a better measurement. So the measurement for better measurement, your torque values should be above 10%.
okay. Torque should not fall under
For,
10.
yes, that's a basic data, right? And
Me-
Brookfield viscometer, as you know, Brookfield viscometer is mostly used in paint industries, right?
Okay, paint industries,
Yeah.
So during stirring, okay, their process itself
No,
is.
no, not during stirring. They are stirring using overhead stirrers. But
Mm-hmm.
for measuring that, what is the viscosity of that paint or emulsion or something that you are applying your like wall and all. So that
Mm-hmm.
you have to measure what is the viscosity number of that particular material, because when you are applying through any roller, it has to have some kind of viscosity, right?
Yeah, yes, sir. Yes, sir.
So if it has a higher viscosity, you are also it is very difficult to spread onto the wall. If it has a very low viscosity, it will also flow through, right? It will not stick to the wall. So it has to be in a certain range of viscosity, so that you can easily apply. Also, it will stick to the walls also, and also it will form certain kind of films in the walls. As I told you earlier, right? कि
Okay.
film formation होता है, quilling होता है, right? So these are
Okay.
the techniques to measure the viscosity of polymer.
So for
For
that is understood, sir. For the second class, glass viscometer you have mentioned, there
yes, yes.
there's some chemical, some liquid is there. Which
Hmm.
particular chemical and in polymer, which stage we are using this viscometer, sir? Glass viscometer.
But look, glass viscometer is using for different polymer. Pair for PET, polyethylene terephthalate, like people have you heard of have you seen the data sheet of PET, polyethylene terephthalate?
I have not seen, sir. PET we
So they have mentioned the grade, and they have mentioned the intrinsic viscosity of that grade. Because PET we usually don't do MFI, right? Instead of MFI, we give a viscosity number. In the case of polyethylene terephthalate, we give intrinsic viscosity number, right? So the more higher the intrinsic viscosity number, that means higher is your molecular weight of that material, right? So for that purpose, PET, we are using intrinsic viscosity. As well as for nylon, polyamide, you have to use relative viscosity, right? And as well as for PVC, polyvinyl chloride, you have to determine the K value. All these tests can be performed through this capillary glass viscometer, right?
Sir, here the polymer is melted and it is put
It
in.
is it is dissolved in a suitable solvent,
Okay.
right?
Okay.
It has to be dissolved in a suitable solvent, and you have to measure its time. And what I have represented here, it is mostly manual method. But now, as Probin told, that all that the machine or viscometer are now automatic, right? They will measure all the time and all, and it will give the data, scientific measurement data. So there, why it is better to be doing automatic for going for automatic viscometer, because you require you do not want to get like the human error in the case of fully automated machine is very less as compared to your manual type of viscometer. So you require an automated machine to measure for accurate measurement of your samples, right? That's what you are doing for automatic viscometers.
Yes, sir. The third quadrant, which is there, no, we used to do this in our powder metallurgy, but this still it is in use for plastic, also polymer, also, sir.
No, it is not is used. I've given this overall what is viscosity. Viscosity is not a topic related to only to polymer. I am giving you the basic. When I go to polymer, then you will see, right? I
Okay.
am just giving Ford cup is used for paint,
Mm-hmm.
right? Many of the paint company, most of the paint now also the bigger company also use Ford cup, Asian Paint all, because they have certain standard, and that standard for that particular flow time of that cup to be empty, get empty, and that time you have to match with the standard value. What is the for that particular time? What is the kinematic viscosity that is in centistokes, right?
Mm,
Therefore, for that purpose, Ford cup is used. It
understood.
is nothing but it is a very manual method. You have to like full the cup, and you have to start the stoppers. Then see how much time it will get empty.
Yeah, yes, sir, yes, sir. That we have worked on it, but in powder metallurgy we have done this. It will be like granule forms.
Yeah, yeah, it will flow. Powder will flow from this. Yes.
For powder metallurgy, this is must we used to do that.
Yes, Praveen, any question?
Thank you, sir. Thank you, sir.
So when we go for viscometry and versus rheology, right? So most of the viscometry techniques does not have the curve, right? It only measures and give you the value. Unless and until now that there's coming the nowadays the viscometer, automated viscometer, they will provide curve, right? Right, Praveen? Praveen? Hello.
Yeah. Actually,
I think your
network
connection is
issue. That's
unstable.
why I'm not able to.
Sorry.
Actually, my network is not stable. That's why.
Yes. So your viscometer is giving some like data, right? Curve, like viscosity curve, or it is giving an
Yeah, it is giving some. Yeah.
right. So nowadays there is viscometer that can give you
Yes, sir.
curve,
It is.
but previously most of the viscometer are only give you a single point data. But whereas rheometers, what happens? Rheometer gives you a dynamic range of data or change in viscosity as as you proceed, right? For rheometer, what you are doing, you are going from low shear rate range, like where shearing the material means you are just shearing means what? You are just reducing the viscosity of any material. So the more the shear, the viscosity will reduce more. So this is the, if you see, this is the low shear range, right? And as you go forward, the shear range is more, right? So if the shear range is more, then your viscosity will be drastically decreasing, right? So this kind type of curve, if you want to analyze it, that curve you can only analyze through rheometry data, right? Or rheological behavior of polymer. This type of behavior when you are studying the, when you are dealing with the nature of your curve, what is the nature of your graph, then you are going for rheology. When you are considering only a single point data, then you are going for viscometry, or you are only considering the viscosity of curve, right? So viscosity is nothing but the obtaining absolute result following SOP and matching quality, while his rheology is dealing with the obtaining dynamic result, generating SOP and defining quality control, right? So, what are the basic of rheology? As you know, like most of the polymers, it only has two portion. One is a viscosity part and one is a elastic part, right? What do you mean by viscous part? Viscosity part means the thing that is completely viscous and it has a delay response to it, like tar, right? Coal tar and all. It is completely viscous, right? So, polymer does have a portion that is completely viscous and also has a portion that is somewhat elastic also, right? That's why polymer are mostly known as viscoelastics, right? So viscoelastics, why it is so? Because when you are melting the polymer, right, before applying a particular prominent shear, right, it is mostly using like a sticky mass. So when you are started to apply this polymer, right, so so when you apply the certain amount of shear stress to the polymer, it will started to reduce its viscosity, right? So when the viscosity will reduce, then it is mostly, sorry, it has to reduce its viscosity. While why it is so? Because you are applying more shear stress to it. So the polymer chain, the chain inside the polymer start to mobilize, right? Mobilize means you start to slide past each other. So your viscosity anyway going to reduce in the case of uh, this polymeric material, right? So polymer is a two part. One is your viscous part and one is your elastic part, right? So in viscous part, the viscosity defined as the quantity that can describe a sample resistance to flow in a contradiction to quantity as plasticity, elasticity and all, right? So a sample is forced to flow by certain force. As I told you earlier, when required, you have to apply a certain force to flow the sample. When force is removed, the sample stops to flow, and this is described by dashboard. Dashboard means this is a just a what you can say, a diagram how fluid flow, right? This is a described experimental diagram. So how a fluid flow. When force is removed from the sample, the stops to flow. This is described the quantity called as dashpot. This dashpot is a symbol for Newtonian flow. This is more into the basic of rheology that you don't have to remember, but just remember what the polymer are mostly in the nature of viscous and elastic. It has it has some part which is completely viscous and it has a part somewhat elastic. So when you are dealing of polymer, so you are dealing with a viscoelastic fluids, right? That has a viscous nature also and elastic nature also. Got it? So these are the basic of rheology, like the most of the graph, that is viscosity versus shear rate, right? So some of when viscosity is completely, the viscosity graph is completely parallel to the shear rate, then it is known as a Newtonian fluid, right? When it is a this your when your viscosity is reducing, right, then it is a shear thinning fluid and it is known as pseudoplastic fluid or shear thinning fluid. When the viscosity is increasing, it is a shear thickening fluid and it is known as a what? It is known as a dilatancy fluid, right? So these are the basic graph, right? And this material, it is known as when you apply certain amount of shield stress, as I'll tell you, some of the fluid might flow, and this is known as a Bingham plastics. So this is the basic different type of fluids that we are dealing with. But most of the time, mostly the polymer that we are going to process and study, and we are dealing with daily like thermoplastics, it is comes under the shear thinning fluid. When you are applying certain amount of shear stress, shear strain, it will started to lose its viscosity, right? That's why it is known as shear thinning fluid. So these are the typical examples of Newtonian fluid, that is water, honey, and organic solvent. It is known as a Newtonian fluid. Whereas in Bingham plastic, required a yield stress to flow. So mostly toothpaste and all. When as you can as I given the example, like toothpaste, you have to apply certain kind of stress to get out the paste from the tube, right? So that's why you are applying the stress. So for that particular stress, the Bingham and plastic is certain nature that you have to apply certain stress, then it can easily flow the fluid. So that's why it is known as a stress fluid, or you can say a Bingham plastics, right? Or what is pseudoplastic? That is shear thinning. Most of the polymer melt, solution, emulsion, these things are shear thinning fluid. What is dilatancy or shear thickening fluid? Most of the cornstarch, right? Some of the jelly starches, these are known as dilatancy fluid. When we apply certain amount of shears, then it started to increase the viscosity. That's why it is known as shear thickening fluid. Understood? What is the basic type of fluids? Yes. So uh, again, this is the data. This is the data for viscosity versus shear rate, right? So this is data deals with the different polymers and how the viscosity and rheology comes. So this kind of data, if you see certain type of materials and polymers, the data will come in this range, right? So this is the nature of the data. It will first state is the viscosity, then after a particular state, when it started to move past each other, the polymer started to move past each other, then it will slow a shear thinning behavior, right? So that's why this is known as a uh, polymer are known as a shear thinning fluid, right? As you can see, the basic example of honey is you are seeing a Newtonian fluid, while in hair gel you are giving a non-Newtonian fluid, that is shear thinning fluid. So most of the polymers are non-Newtonian fluids and comes under the category of shear thinning or pseudoplastic fluid, right? So this is also data. These are typical data. This is like when they are applying certain amount of frequency to the polymer, measure its viscosity, complex viscosity. So what is the response of the polymer, right? And what is the significance of this when your polymer flows from like when you're giving a certain amount of frequency strain, right? Strain frequency. So how your polymer behaves, right? So as I told you earlier, in that DMT, there are also loss modulus, storage modulus. Here also fluid you can easily do that test by applying certain amount of frequency to the polymer, right? Polymer melts and you are seeing the crossover. If the crossover is more like here at lower shear range, low frequency, then your polymer is mostly elastic. If it is, goes to a high shear range, then your polymer is mostly viscous nature, right? So these are the different fluid and their processes, right? So most of the processes like sedimentation, storage, leveling, right? And this is the shear range of that processes. Extrusion you can easily see as you deal with polymer, it is coming around 1 to 100. Then mostly leveling of paint, as I told you, it is a very less shear fluid, less shear process, whereas extrusion is comparatively high shear process. Injection, this value will go about to 1000 and above. So as the why giving you the example, because most of the processes has like a different range of shear to it, right? So mostly injection processes generated more shear to the fluid to be flowed, while as relatively low shear process are extrusion, blow molding. These are relatively low shear process as compared to your injection molding process, right? So why it is important? Because when you are applying more shear in a process, so there may be a chance of getting more flow from it. So while you are getting a more flow from that process, then you require your material to be designed in a certain way that you are compromising the, you're restricting the flow, right? So these kind of fluids you have to be designed, right? So this kind of polymer have to design and understood what is the flow behavior of that particular polymer. So you must be it must be like mostly uh what you can say new to all you all. But this is the basic graph that we are getting from any kind of rheometry rheological measurements, right? So again, this is also the same thing. We are getting any kind of MFI and rheometer. These are the data that you can easily get. This is the shear viscosity at different temperature of polypropylene. As you can see, if the temperature is increasing, it is going from this to 20, then you are getting a what? You are getting a reduction in your viscosity. So if you get a reduction in your viscosity, then flow will be more. So this is the temperature dependency of any polymer that has been here, because the temperature range from 185 to 200 and 210 to 220. This is the range that the fluid will flow, right? So they are just analyzing the temperature, and with respect to that temperature, they are analyzing the what is the viscosity of that particular polymer, right? So that's why rheology is more important technique to measure the flow behavior of any polymer, right, based on its characteristics. So what is the nature of graph? If you want to study, if you want to study the scientific data, how it is related, and what are the uh, science and analogy behind the flow, then you have to go for rheology. That we don't require in day-to-day like skill, like in the industry. Yes. अरे क्लास ले रहा हूँ मैं बाद में कॉल so these are the data that the rheological data that we have performed in our lab, right? You can easily see the viscosity and all as the temperature increases and how viscosity has decreases. You can easily see that this is the increment in temperature, and you can easily see that this is a decrement in viscosity, right? So this all thing happen that you can easily got through rheological measurements through rheology, that you can easily find out a single point value through MFI, right? As you increase just the temperature and do MFI, you will get a higher the temperature, you may get a higher MFI, right? Same polymer, if you do at lower temperature, and same polymer you are performing MFI at higher temperature, you might get a high MFI at high temperature, and you will get a low MFI at low temperature, but that is a single point data, right? So if you want to see the over range of data, like from low shear range to high shear range, then you have to go for a rheological measurement. So that's my concern. So most of the test that you want to perform or rheological test that you want to conduct, so you have to analyze or something, do something like uh, uh, the research and do the rheological measurement. Then you have to go for rheometry, right? You could not, because only MFI is for quality control and service to the customer, but it does not provide any scientific significance data that we can analyze through why it is improving and why it is reducing, why the MFI is increasing and the temperature is increasing, right? Why MFI is reducing when they were reducing the temperature. That only you can find through rheometry, right? Am I audible to all? Hello, hello.
Yes, sir. Yes, sir.
Am I
Yes,
audible?
sir.
Do you understand what I have told? Like somewhat. Hello. Have you understood? Like
Yes.
somewhat, like why rheology is important?
Yes, sir. Yes, sir.
Why it is important? Because you if you want to measure, right, any kind of behavior of polymer, then you have to go for rheology, because MFI only is going to only give you a single point data at particular temperature. So MFI, so whereas rheometry will give you a range of data, right? So that's why rheology is more important when you are going for a scientific study, right? So so that is the basic of what are the why rheology is important, right? So if somebody asks you why rheology important, you can easily say that if you want to measure the nature of graph or nature of curve, right, then you have to go for rheological measurement. It cannot be measured through any kind of viscosity measurement. So that's why rheological measurement is more accurate tool to analyze the polymer viscosity behavior. Got it? Yes.
Yeah, yes, sir.
So this is the, and again this is the all the data that while the single cycle analysis, when you give it to 4 cycle, then your viscosity anyway going to reduce, right? For PET, polyethylene, tetracycline, as I told you earlier, the more the thermal cycle, the more the degradation of polyesters, right? The more the degradation, your viscosity will be going down. So these are the data based on degradation. If you can see, this is the first cycle, you are getting a higher viscosity, right? Where in the second cycle you are getting a moderate viscosity, then third cycle even, and fourth cycle the viscosity is quite low due to thermal degradation, localized thermal degradation. Same is the case of polymer, same is the case of PP, polypropylenes. If you increase the viscosity, also if you increase the number of cycles, also you will get a thermal degradation. That is shows here. Right, all these data you can analyze through rheological measurements, right? Because because this data is suitable for where you are talking about reprocessing, right? Recycling, reprocessing, because you are again and again exposing the polymer into different thermal cycles, right? You getting my point?
Yes, sir. Yes, sir.
So
Yes, sir.
when you are using any recycling polymer, so you will see, just probably if you are using some recycling PET and polyamide, you can easily see, easily correct me if I am wrong, because virgin polyamide has a higher viscosity range than recycled polyamide, right?
Yes, sir.
Virgin polyamide has a higher relative viscosity than recycled polyamide, right?
Yes. Recycle is having low viscosity.
Yes, because it is already thermally degraded or it is exposed. So that's why for that purpose, if you go for rheological data, it is more suitable to analyze, right? At what point it is started to the like lose its viscosity stability, because anyway this data will many will help you in different processes like injection molding and all, right? So you need to find out the nature of curve, nature of graph, what rheological measurements give, right? So uh, this is nothing but a somewhat like relation. What is the shear stress data? What is shear stress is nothing but a force divided by area, whereas shear rate is nothing but your derivative of your velocity with respect to your y-axis. Like what is the rate of shear means what? You are dividing shear stress divided by viscosity, and you are just applying a velocity and you are measuring its deformations, right? So that is related to the shear rate, right? Whereas shear stress is your nothing but your simple for what the whatever the force you are applying at a particular area, that is known as shear stress, right? For neutral and fluid, shear stress is directly proportional to shear rate, right? So most of the neutral and fluid like water, honey, these are your shear stress is always directly proportional to your shear rate, right? So whereas in uh, non-neutral and fluid case, it is not. It is not proportional to the shear rate. The shear stress is not proportional to the shear rate. So these are the formula that stress when stress is divided by strain rate, it is known as modulus, and when stress is divided with the shear rate, and it is known as the viscosity, right? These are the basic formula, right? And this is the basic graph of shear stress versus shear rate for a Newtonian fluid. It will always directly proportional. So viscosity anyway not going to change. It will remain parallel to the your y-axis, that is in shear rate, right? So most of the Newtonian fluid like water, milk solution, sugar solution, all are Newtonian fluid, right? So I told you earlier that shear thinning is eta will be decreasing with increasing shear rate like most polymer. In most polymer case, we are getting a shear thinning behavior, right? Where your eta or viscosity is going to always decrease with the increasing of shear rate, right? Like they have given the example like pseudoplastics. The pseudoplastics, just shear thinning is comes under the pseudoplastics, and these are the example: paint, shampoo, slurries, polymer melt. Polymer melt is nothing but whatever we are dealing the thermoplastic polymer, that is polymer melt, right? Just shear thinning fluid, and this the viscosity that you don't like much understand from it. Whereas you just remember in shear thinning when you are applying shear rate, your viscosity is decreasing, but when it's shear thickening, when you're applying shear rate, your viscosity is increasing, right? So the more the shear rate in your shear thickening fluid, you'll get a more high viscosity, right? That is known as dilatancy, that is constant solution and all. If you are applying more shear stress to it or more frictional stress to it, then your viscosity will be increasing. Whereas in shear thinning like polymer melt, paint, emulsions, when you apply more viscosity, your viscosity is going to get reduced. Got it? Hello.
Yes, sir.
And Bingan plastic, as I told you earlier, like tomato paste, ketchup, it requires certain amount of stress to flow, right? Hand cream, grease, toothpaste, these all are comes under Bingan plastics. Bingan plastic, you require what? It will act as a behavior of fluid where you require certain amount of shear stress to flow that fluid, right? In any kind of tube, right? That you are using like cosmetic product like Fair and Lovely, Fair and Handsome, whatever the cream, you have to apply some stress to get the product out of the tube, right? Am I right or not? Hello, hello.
Yes, sir. Yes, sir.
So for any kind of gel and all, you require to be applying, you require to apply certain kind of force to it, na, to get the product out of the that particular packaging, right? So
Yeah.
that force is known as yield stress because you are applying the stress to flow that fluid. So that particular type of fluid is known as Bingan plastics, right? So these are the different types of fluid that can be flow, and this is the different type of fluid that can be measured through using the rheometer. That is my concern, right? So so our most like more prominent thing is pseudoplastic behavior, that is shear thinning, right? And dilatancy is shear thinning. So we will not go into dilatancy because none of the polymer melt will show this dilatant behavior, right? But or most of the polymer component will show you this pseudoplastic behavior. Pseudoplastic behavior means it will show you the shear thinning behavior, right? So by analyzing the shear thinning behavior and analyzing the range of shear thinning behavior, you can easily analyze the nature of your polymer that you are using, right? So let's come to the like industrial point of view, right? How you measure the viscosity, right? Then and uh, what are the different tests and methods through which you are going to measure the viscosity, right? So everybody knows MFI. So you know MFI, right?
Yes, we know.
So MFI is what? It is defined as the measurement and rate of extrusion of molten resin through a die of specified length, right, and diameter under a prescribed load, right, for prescribed load condition of temperature and pressure in 10 minutes, right? And you are getting a data of MFI of gram per 10 minutes. What? Because what you are doing, you are applying certain load, right? You are filling the barrel with certain polymers and certain type of polymer. You are applying load, like you are keeping the polymer for 5 minutes or so, 6 minutes
Yes, in
soak time.
MFI, we are also testing that melt density and melt volume rate.
Melt volume rate also you are doing, and melt density also you are doing, right?
Yeah.
But
To find
which
out the
type of
melt volume
geometer,
rate,
which company MFI machine you have?
international equipments.
International equipments.
Yeah.
Okay. So anyway, in MFI machine, there are three type of tests you can measure. You can either measure the melt flow index. You have to measure, if you want to measure, you can measure the melt density of polymer. Also, you can measure the melt volume rate of matter. Right? Certain polymers, certain supply required melt volume rate, like for polyesters, PET, and all, they required melt volume rate instead of MFI. Right? For polyamide, they require melt volume rate. For PCAPS and all this kind of system, they always require melt volume rate to be known. So a certain time you require melt volume rate also to be measured, and certain time you require melt flow rate to be measured. That is MFI or MFI to be measured. But these are the different units. Like MFI is the unit of gram per 10 minutes, whereas MBR, melt volume rate, is a unit of centimeter cube divided by 10 minutes. What is the gram centimeter cube of metal that is injected through a die, extruded through a die for 10 minutes, right? So these are the different methods to determine. So the most are there are two methods that in which you can determine the uh, flow of any polymer. One is STMG 1238 and one is ISO 1133, right? So ASTM 1238 and ISO 113, these are two international methods that is most widely used to determine the flow property of polymer, right? So what are the apparatus required, but what are the constituent of any MFI machines? One is your test sample you require, right? One in it is a steel cylinder, die, heater, piston, load, thermometer, and weighing balance, right? Weighing balance you are going to measure the whatever the weight comes from that extruded die, right? Thermometer will measure your temperature, load you have to provide, whether it is a 2 kg load, something 3.18 load, 2.16 load, 5 kg load, whatever the load, you have to measure, you have to put in the machine, and that machine will test your MFI value according to that, right? This is nothing but the what is the test sample, right? What is the powder, granules, film. So this all can be done melted, but it has to be a thermoplastic characteristic. So it should melt at certain particular temperature, pressure, right? So that you can measure the MFI. If a sample does not melt, you can't measure its flow rate, right? These are the load like 0.325 kg, 1.2 kg, 2.16 kg, 3.8 kg, 5 kg, 10 kg. These are the standard load that MFI machine uses, right? And
Yes, sir.
you can easily find out the flow rate by using the by determining the mass that is determined for per 10 seconds, 20 seconds, whatever the time you have taken, that they have to put the mass here and put the time here, and you have to multiply by 600. That is nothing but the you are multiplying it by in 10 seconds, right? So 10 minutes, right? The 600 second is your 10 minutes, right? Whatever this ratio will come, mass divided with time, because anyway for different, for high flow polymer you will require, maybe requiring low time to cut the specimen, right? For high MFI machine, you have to cut the specimen, you have to cut the sample at a very low time, like low time span, like 10 second, 5 second, right? For low MFI polymer, you have to give a more time span to material to flow. Depending upon that, you have to keep the mass measured and divided by the time, and you have to multiply into 10 minutes. So you can get a MFI data, right? So these are the factor influencing what is the preheat time given. So what are the preheat time? If I can remember, for ISO it is 5 minutes, right? Or STM it is 5 minutes preheating time.
For ISO, it is the 300 seconds, and for ASTM, I
ISO
think 240 seconds, I think.
240 seconds, yes.
Yeah.
4 minutes and 5 minutes, right?
Yeah.
So if you are doing MFI, then you have to remove all the moistures, right? Because it does not contain any bubble pockets and all. So if it contains any bubble pockets and all, then your flow will be influenced by that, right? So these are the concerns that you have to see whether your material is completely dry, with and what are the preheating time you are giving, how you are packing the material. The material has to be packed very good, like, and you have to provide proper packing to the material so that the appropriate material is homogeneous packing should be applied to all the part of metal, so that when you are going to apply the load, it will flow more, like uh, it will flow more steadily than other, like if you are not packing the metal good, and if there is some type of moisture trap present in the machine, then your flow of material will be discontinuous, right? So you have to be you have to make sure that your material is completely dried, moisture free, and you are giving a good packing to the material, so that it cannot, there is no entrapped air between those melt, so that your material can easily started to flow, right, when you're applying the load. So this is the basic concept behind the MFI machines, right? Physical form of material, it can adhere around 2 to 8 grams of samples, right? And you can easily use granules and all. So MFI is nothing but the measuring the standard viscosity methods for measuring the flow behavior of any polymer at a particular load. If you are measuring the flow behavior of any polymer at a particular load, eh, and load and pressure, right? That is known as MFI, right? So whenever you are MFI mentioning the MFI of any polymer, you are mentioning the load also and temperature also. So suppose I am going to PP and I am providing MFI, then you are what you are doing is PP, then it's a standard load is 2.16 kg and temperature is 230 degrees Celsius, right? So MFI only give you the viscosity data of or polymer that you are testing, right? Then comes to viscosity, right? So what is viscosity? As I told you earlier, there are, as I've given the standard to about MFI also, there are certain standard of viscosity also to determine the polymer viscosity. As I told you earlier, there are two type way of you can measure the viscosity. Either by you can do by manual methods, in manually you measure the time and calculate the viscosity, or you can go for a automated machinery methods, right? So most of the polymer industry, they use automated machines, right, to measure the viscosity of polymer, right?
So, sir, here the test method is it is mentioned ISO 1628, but
Yes,
we are mentioning test method ISO 307 for the viscosity measurement.
yes, you are using ISO 307.
Yeah.
Look, the dilute solution viscosity are different for different. So it your if you are for nylon, it will be different. For polyethylene terephthalate, it will be different. That what the method that you are giving me is for nylon polyamide, right?
Yeah.
That is a specific method that we are measuring. From
Okay.
ISO, this that is a that yes,
It's on different material, different standard will be
yes,
there.
yes,
Like,
yeah,
okay.
yeah. So how to prepare and what amount of you must be preparing different. How you are preparing the solution?
We are measuring the polyamide as per standard, and then we are uh, putting in the beaker. Then, as per solution of S2SO4 in 100 ml, we are preparing, adding the pellets, and we are putting into the shaker bath for mixing it for a
Which
particular
company
time.
machine? Which company machine you told me that you have?
Siskin,
Tiskin. Can
Siskin,
you
yeah,
spell Siskin?
yeah.
Can you spell it like
SKI, SIS,
KI?
SKISKIN, like that only. I have to check this.
Okay, so
Why?
that machine you are using.
Yeah.
Okay. So you are whether you are preparing a solution or of different concentration or same concentration.
Means same concentration, but of polyamide 6 and double 6, filled and glass filled both,
Okay.
filled and unfilled both.
So it will give you a viscosity versus shear rate data. It will give provide.
Yeah. We only need the viscosity number, how much viscosity number it is coming. For that, we
Yes.
are performing.
Yeah, that's what I'm saying. Now only MFI machine will only give you a viscosity graph and number,
Yeah.
and that you want to perform. So if you go for any rheological measurement, then you go for rheometry, right? Because rheometry will give you the number viscosity with respect to the shear rate, right? So that's the basic idea of why viscosity and rheology, why rheology is important over viscosity. In certain cases, you can't rely on the viscosity, because when the shear rate of any process changes, right, the viscosity is anyway going to change, right? If you are processing the same material in poly, like as you know better, like the grade, like if you are getting a grade of polyethylene that is used for extrusion, right? The same grade polyethylene you can't run good at injection molding, can you? Because it has a high viscosity. For extrusion grade, they require high viscosity for polypropylene. Whereas for injection molding, they may require a low viscosity polypropylene. Why? Or low viscosity polyethylene. Why? Because in injection molding, you require a mold to be flow very quickly. But extrusion, you can't do that. For extrusion, for most of the extrusion process that in the industrial scale, like film blowing, film casting, pipe extrusion, all these things require a certain amount of viscosity to the material to stretch. For that, you require a high viscosity. High viscosity material you can only stretch. You cannot stretch a low viscosity material. If you want to stretch a low viscosity material, then your best material will be your some product will be get damaged, right? और आपको प्रोडक्ट ब्रेक हो जाएगा, उसका स्टेबिलिटी नहीं आएगा. So for that purpose, you require a little bit of high viscosity material. So whenever whatever the industrial manufacturer they're manufacturing certain grades, they always check this kind of property, like what is the viscosity, what is the elongational viscosity, what is the shear viscosity of any polymer, while they are specifying the application. So for different application, there are different viscosity to be required, right? For injection molding, it requires a little bit of high MFI polymers, while for extrusion, you may require a very little bit of low MFI polymer as compared to injection molding, right? Because the injection molding process has a high shear rate as compared to extrusion process. Got it?
Yes, sir.
Yes. So this is the capillary methods to measure the viscosity, right? You can easily measure the viscosity through different methods. You are measuring relative viscosity, you are measuring intrinsic viscosity, These are the different type of viscosity that you can measure, where by measuring the viscosity, you are also can be measuring the uh, uh, molecular weight through this equation, that is Mark-Okin's equation, right? So this is very what like many technical, so do not understand like more into this. So just remember that viscosity, as the concentration of any solution is going to increase, then viscosity number is always going to increase. For integrated scale, it is always a specified concentration that you are mixing the polymer and you are determining the viscosity. Right. If you just Probin can do some experiment, right, yet here and for your understanding, if you just whatever the weight you are taking, how much weight you are taking for 100 grams apple, 100 gram of solution, 100 ml of solution. Hello. Hello.
Yes, sir.
How much sample you are taking for 100 ml of solution?
Uh, means 5 reading we are taking.
Sorry.
Means the reading you are asking.
No. How much
The
sample you are taking for 100 ml of solution?
uh, if it is unfilled, it is 0.5
0.5 gram
milligram. 0.5 milligram.
for 100 ml.
Yeah, for 100 ml.
0.5 milligram. Okay.
Yeah, for
So
viscosity measurement.
this is the standard, right? Always you are taking 0.5 milligram per 100 ml and you are measuring the viscosity, right?
Yes, for the unfilled material, we are taking 0.5 milligram
Mm.
for the viscosity measurement.
Okay, so
Actually, this is
if
for the relative viscosity. For relative viscosity, we are taking 1 gram.
1 gram from
1 gram for 100 ml.
for relative viscosity,
Yeah, for relative viscosity.
or per 0.5 gram for or 0.5 gram for what? Then
0.5 for viscosity number.
okay, so to find out with the viscosity number. Okay.
Yeah.
So if you can increase the viscosity, the gram of sample, weight of sample, then you can easily see the viscosity value will increase, right? So it is always the vice versa, but don't do the machine because machine may get choked, right? The tubes.
Yeah.
Yeah. But if you have a manual viscometer or you have a manual stepper, you can easily see by preparing solution. You can easily just see whether you are like if you are going to if you are anyway increasing the polymer, your viscosity number will be increasing, right? The polymer will get more viscous. So that's my idea. So to understand you, so
What
how
can you
viscosity
repeat?
is changing.
If we are having manual viscosity meter, what we can see?
If you are having manual viscosity measurement meter, then you can
Yeah.
easily see if you can increase the weight, increase the sample size, and you can easily see the viscosity value will be increasing. Like,
Yeah. Means
yes,
if we increase the quantity of the sample while preparing, the viscosity number will change automatically.
yes, matlab, if you are increasing the concentration, viscosity number will be changing, na? Anyway. Because that's why you are defining viscosity. Always you are doing why you are doing 0.5 milligram, because this is the standard to measure, right? Hello.
Yes, sir.
Why you are doing 0.5 gram? Because that is mentioned in the standard to
Yes, it is
measure the viscosity
mentioned.
number, that 0.5 milligram should be taken in our number. For if you want to see whether what happened when you have take 1 milligram sample, then you can take also, you can check the number will increase.
Yes, the number will not match with the TDS of the sample which we have
Yes,
received.
yeah, yes. So that is the thing that always define out. It's in industrial scale. It always happens in standards, right? What are the standard description they have provided? But in research scale, in research institute like us, what we do is we always do R&D. What if you increase the sample size, what will happen? If you decrease the distance, what will happen? How the graph will behave? How viscosity will behave? That we do generally, right? So that is my concern. So whenever in industrial scale, you have to always follow the SOP, right? That is there.
Yes, sir.
So these are the different numbers of viscosity, right? Relative viscosity, specific viscosity, and reduced viscosity, right? So as I told you that that is also that inherent viscosity also, and then you have got we are going to intrinsic viscosity, right? So this is the relative viscosity is nothing but the ratio of viscosity of this eta, that is viscosity number of your solution divided by viscosity number of the solvent, right? Then time given by your solution divided by time given by your solvent, right? So these are the different viscosity number. Right? Like n specific is nothing but this n eta minus eta 0 minus 1. And if you convert it to, it will get like eta minus eta 0 divided by eta 0. So these are the numbers where you just define the viscosity of any polymeric solution, right? So why I'm giving you example, because most of the like some of the polymers we does not we can't do MFI, or MFI is less important, like polyamide, where you can go give MFI value or MBR value, but they also require a viscosity number value. In that case, you have to measure the viscosity of polymer, right? So in certain polymer, you require also MFI data as well as with your viscosity number data, right? For that polymer, you have to measure the viscosity of the polymer through this viscosity method. Also, the Brookfield viscometer, as I told you earlier, it like that is a capillary viscometer that you have said and that you are using. Also, Brookfield is also used. In Brookfield viscometer, what happens? There are different types of spindles that is used to measure the viscometry of polymer solution, right? In that different type of spindle, what you are doing, you are you are putting the spindle, you are measuring the viscosity at particular RPM. When you are measuring the data, or when you are giving the data, you have to measure the give the spindle size also. For this spindle size, this is the viscosity at this RPM. So that is known as Brookfield viscometer. Brookfield viscometer is a most widely viscometric technique that is been used for measuring the uh, viscosity of any kind of emulsion, paints and all, or plastisols and all. Also the different kind of viscosity of any kind of thermoset plastic like epoxy, emulsion and all, right? So as I told you, first you have to select a spindle and upper portion of the viscometer at higher rotation speed to use. Insert the spindle approximately at an angle of 45 degree. Move the sample so the center of the spindle is there. Adjust the depth of immersion mark. All these things while you are operating the machine, you have to see how, where is your spindle, whether your spindle is correctly attached to the motor or not, whether your spindle is completely deep uh, uh, inside that uh, sample or not, whether whether it is centered completely perfectly centered or not, right? So first, what you have to do, you have to move the viscometer at a lower speed, then you have to increase the speed stepwise, right? Then placing it in a constant temperature bath, specifying the test temperature conditions. These all are to be there. So whenever you are providing viscosity, you're measuring viscosity, you have to make sure that your machine has been calibrated properly. You are using the proper spindle for measuring the viscosity, and you are having a like proper calibration of the machine so that whatever the viscosity data you are getting from Brookfield will be correct, right? So the data that you are going to when you are going to get from Brookfield, it will always in centipoise. So this is the range of spindle and what is the factors and all. Then this conversion table, if you want to calculate, then you can easily use this table, right? And you have to calculate the viscosity. Again, this is the diacetyl dilute solution viscosity as I told you earlier. Then K value, and K value is mostly suitable for PVC. The higher the K value, the process is like the higher K value PVC goes for extrusion. Then if the low K values go for something like plastisols and all. This K value defines the flow property of PVC. As I told you, like intrinsic viscosity defines the flow property of PET, whereas relative define viscosity defines the flow property of polyamide, whereas K value also defines the flow property of polyvinyl chloride, right? For polyvinyl chloride, you have to find out the K value to understand the process, right? So other than this, there are other things like other than viscometer and rheometers, there are other things that also can be used to measure the flow of polymer, right? One is, pot cup methods. Every Hello, hello, am I audible?
Yes, sir.
So, as you told me, like you have worked in powder coating, or what you have told me, powder what? Right.
You are asking Pavan, Pravina?
Now, I'm asking what you told me that you have worked on some of the thermoset powder, right?
Yeah, yes, sir. We are, I am from Breaks India. We are having a compounding products for
So you
engineering.
are you are working on brakes.
Breaks India.
I know brakes India.
Yeah, yes, sir.
So you are on which plant like Mysore?
Mysore plant, yes.
Yes. So you are compounding what materials?
We are compounding polypropylene, PC, ABS,
So
and
what are the machines that you are seeing?
we have
Like
tensile DSC,
uh,
MFI, and
okay.
reflection, this thing. Then
What?
that deflection testing, no?
Okay,
Deflection
SDT,
temperature.
SDT.
Deflection testing
SDT. Okay.
that we have, and then wire, this thing, fire,
Okay.
heat.
So other than MFI machine, you do not have any kind of machine that can measure the flow. Do you have spiral flow test at your end?
Spiral flow. No, sir. Spiral flow we have.
Yeah, that is
Yeah,
there. Na? You are attaching in the injection molding mold and you are doing spiral flow.
yes. Whenever we have a problem in MFI, we used to do this.
Yes. So what do you measure from spiral flow? Just give me example. I don't want to go to slide. Why you are doing spiral flow? Just can you just tell me in layman language? If you can tell me, then I because
Uh,
I don't know whether you are interested
yeah.
uh,
Actually, there will
really. Yes. Okay.
after the screw, there will be some five circles will be there. If
Okay.
as much as if it is extending 6 or 7 circle will be a normal flow.
Okay.
If it's lesser than 5, then there is a
Hmm.
problem in the material. Like that, each material will have the number of circles, how much circles it can flow. With that, we
Okay.
conclude whether it is good or bad.
The more the flow length, then more the lower the viscosity, right?
Oh, yes, lower the viscosity. So in that, we check that one, viscosity.
Okay. So why it is because why you are doing in injection molding, right? Because whatever the material you are manufacturing, right? That material cannot when you are testing in MFI, we are giving a static load, right? We are giving a static load 2.16 kg, 5 kg. That load does not replicate the actual shear that your material is getting in a process, right?
Yes, sir.
So whenever you are applying that material, you are putting that material in a spiral flow. What you are doing, you are giving shear to the material. You are injecting at a high speed, right? That material. Then what about your material is induced to higher shear rate in the case of machine condition like injection molding spiral flow. You are getting a higher range, right? Shear rate range in injection molding. That's why it is more acceptable to see the spiral flow data with MFI data. If you can correlate the spiral flow data with the MFI data, then you will get a like good understanding of layman of what is rheology is, right?
Yes.
Also, if you want to measure the any rheological behavior of any polymer, do keep the temperature constant, like 210 to 30, whatever the temperature it might be. Just increase the load. First MFI, suppose you have done like 0.68 kg, second 1.2 kg, third 2.1, same material you will do 2.1 kg, 16 kg, then you do same thing in 3.8 kg, 5 kg, 10 kg. Just see how MFI changes as load increases, because if you are going to increase the load from load to higher, as load increases, the stress increases. If stress is increasing, the shear rate will be increasing in the barrel, inside the MFI barrel. As shear rate is increasing inside the barrel, MFI barrel, you will get a relatively high MFI data as compared to load, like low load. In higher load, you will get a higher MFI as compared to lower load, right? So my concept is, when you are increasing the load, your MFI will be increasing. So for analyzing that and replicating that sort of things, you are going for spiral flow, because spiral flow, your shear rate will be higher, right? And
Yes, sir.
you are what you are doing, you are putting your material to a dynamic shear range, right? Dynamic range means your screw is rotating, your material is getting churned out, and it is getting sheared, and what happens, your screw is pushing that material, right? So the more shear will be developed on the material, so the higher the shear, the flow will be better, right? But to analyze the better practical condition, we are doing the what, spiral flow test, right? To understand the better flow behavior of your polymer, right?
Yes, sir.
So whereas in the case of thermoset, there is a test known as cup flow test, right? Have you heard of thermoset cup flow test? There is a particular type of cup where you are pouring the cup and you are just curing it, and you are seeing how much cup flow it is there,
No, we are not sure.
because you are only dealing with the
Engineering.
thermoplastics.
Yeah.
Yes. So cup flow test is mostly used for thermoset. This is also a cup shape cavity dimension test, where you are measuring the flow behavior of any thermoset powders, right, through the test. So that's why it is known as a cup flow test. Also, you are evaluating the moldability of any kind of thermoset powder, right?
Yes, sir.
So this is a standard. So that's why I'm asking, are you like any this spiral flow? Because in spiral flow you are doing in a machine, cup flow you are doing in a particular type of mold. What is the moldability and all of that particular thermoset? For that, to replicate the process condition, you are doing spiral flow in injection thermoplastics. In cup flow, you are doing for thermoset, you are doing cup flow, right? So this is the different condition for measuring the cup flow. For phenolics, it is 165. For melamine, it is 155. For urea, it is 150. Epoxy is 150. For diallyl phthalates, it is 150. For alkyls, it is 150. Right. For why? Because the moldability of different temperature of for different polymeric material at different temperature, we have to perform the cup flow to see the what is the moldability of that particular material, right? And you have to apply certain kind of pressure, like total load and what is the pressure, molding pressure to that particular material to mold. The higher the molding pressure, that means higher the viscosity, right? Higher amount of pressure required means higher the buildup of the viscosity, right? And spiral flow, as I told earlier, like spiral flow, the spiral flow should be measured at different temperature, right? For different polymer, for polypropylene, it will be different temperature. For polyamide, it may be different. For polystyrene, it may be different. But according to the standard, it should be measured. For spiral, for different polymer, there are different conditions to measure the spiral flow, right? You also have certain process condition to measure the spiral flow. You want to put the, like, what should be the injection pressure, right? What should be the injection speed, right? This all these things should be taken into account while we are doing spiral flow test. So As you can see, the MFI data polypropylene, right? This polypropylene is deal with the spiral flow, right? So this is the correlation, as I told you earlier, right? If you can correlate it, then it is very better. When you are correlating something like MFI data with the spiral flow, right? Then you are getting a better idea about how your material is going to behave in process condition. What it?
Yes, sir.
You are also doing the spiral flow in your company?
Hello.
Yes. Yes. Hello. Hello.
Hello. Yes, sir.
You are also doing spiral flow in your
No,
company?
no, we are not doing. We are not doing.
Because spiral flow is in, if you are working on polypropylenes and all and injection compound like ABS, polycarbonate, then many of the people do spiral flow, right? So if you can analyze the spiral flow data with different MFI, it is very good to understand what is the dynamics of material that is going when we are doing processing, how it changes, right? When we are going a low MFI PP, so how much pressure is required while we are filling the that particular mold. If we are going for a higher MFI, then what will be the dynamics of pressure, how it is changing while filling the mold. So these all these things should be measured through spiral flow test, right? Then there are certain tests for elastomer also to measure the viscosity, like Mooney viscosity, right? When we are going for rubber, if rubber has a certain viscosity number that is specially designed for the rubber, it is known as a Mooney viscosity number. The higher the viscosity number, the lower the flow of this rubbery material, right? For that, they have a stationary disc and a movable disc. In between that disc, they have to determine the viscosity of that particular rubber. That viscosity is known as Mooney viscosity number, right? Then you will get this kind of curve, and where in that curve you will get a scorch time, and you have to get a threshold time of this particular polymer where this your material going to flow, right? So when you're rubber, you have to, why it is important, you when it's cross type call, it started to cross link, right? Where if you are cross linking a rubber or vulcanizing a rubber. So these whatever the techniques we are studying, it related to the different process that is used in polymer industry, right? Polymer is not always about plastic. It also includes paint, right? Paint, uh, emulsions, rubber, right? Also, plastic is a very larger part of polymer, but polymer itself includes many segments. That in that segment we can use different type of viscosity methods to measure the viscosity of, of that particular process or of that particular material. So viscosity is always a tricky subject to understand for many researchers also and many industrial peoples also, because it always deals with the different phenomena like parameters like shear rate, shear stress, right, and temperature, pressure, right. All these things are influencing the property of viscosity, right. So whenever somebody asks you what is like viscosity and all, so normally whatever MFI value and whatever the viscometry value we are doing, we are measuring only the viscosity or with the phenomena of viscosity. But whenever we are measuring any kind of dynamic thing like rheometry and all, then we are measuring the shear viscosity of that particular polymer, right? So there is always a viscosity. There are two types of viscosity. One is viscosity that you are measuring in a static condition, and one if you are measuring something in a shear condition, that is known as shear viscosity. So all this data should be taken into account uh, while you are doing any kind of like analysis and all. So you need to know what is the viscosity number, or for the layman language, if you want to measure the viscosity for the most of the industry scale, MFI is the best way to measure the viscosity, or best MFI and including all these uh, uh, this test, the spiral flow and all for quality control of that particular product, right? If you go higher range, then you may require capillary geometry, which can, if you can get some high shear data, like higher, you can apply high shear and see whatever whether your polymer shear is showing, so is shear thinning behavior or it is shear thickening behavior. That data you can get from the capillary geometry, right? So it is always good to understand little bit of viscosity. That means how your polymer is behaving and at particular conditions, because you may produce some polymer that is a MFI of this, but at particular shear rate it may not get the polymer does not get shear thinning behavior, does not show that much shear thinning behavior, so you may not get good flow, right? For getting a good flow, you may require a shear thinning polymer and all. So for that purpose, you require a rheological measurement. But if you go for layman language, if you are only matching the customer data with the MFI value and all, then you can easily do it by using MFI methods or any kind of molding method such as more your uh, molding method such as this spiral flow or cup flow test, right? So have you understood a little bit about viscosity and all?
Yes, sir. Yes, sir.
So I think this is the last class, right, regarding viscosity. Or any you have completed with your all the syllabus? Hello.
Yet we have to see, sir, see the syllabus and we have to match it. We have not checked like that.
Because
There
viscosity is only left whatever the Pawan had told me, that the basic of viscosity, this is not viscosity. Because viscosity is very much numerical and all. The basic of viscosity, that what they have told me is only left. I think your syllabus is over. From tomorrow there is no class, I guess, from this side.
syllabus for Indian Institute of Plastic, all the syllabus are over. Huh?
I think so. I don't know.
Okay.
Sandeep sir can better answer that.
Sir, can you go to the first one, sir, slide?
This one?
Before this, sir, because first few slides I have not seen. That is why, sir.
Yes. So this is nothing but the introduction slide to what is viscosity, right?
We
As
started
you
from
can see,
today.
yes, yes, I started from here only.
Okay,
Because
then
this is a one single class, this is a basic idea about what is viscosity.
okay,
As
okay,
such, polymer rheology is a very vast topic in engineering, which usually take 40 hours lecture for polymer rheology.
okay, sir.
It's
Okay.
a more dynamics topic like fluid mechanics, as you can go like that topic only. Rheology of polymer. Always is a transport phenomena, right? Whenever
Okay.
you're talking about flow, you're transporting something, right?
Yes. This is the first slide then.
So these are the basic idea of how water flows and how viscosity liquid flow, right? You can easily visualize this, right? When you are pouring water to something and when you are pouring some viscous compound like mayonnaise and all, you can easily see that, and ketchup and all, right? they do have a different flow behavior, right?
Yes, sir. Yes, sir.
So this is a viscosity. This is a basic idea of viscosity. Viscosity is not limited to polymers. You can go up and beyond, like from polymer, food, pharmaceuticals. Like there are different segments that uses viscosity, cosmetics, right? So in polymer viscosity, the MFI numbers, capillary geometry, right? Then this more spiral flow test, Cobb flow test. These are important. Mostly spiral flow test, MFI. These two are mostly used for to understand the layman viscosity of any polymer in the industry, right? Mostly MFI, like the different weight and all, different temperature and all, right? So different polymer does show different type of MFI. There are some polymers which are high MFI polymers, right? There are low MFI polymers, right? So depending upon that, you require a process, right? For some of the injection molding may require a high MFI polymer, while is the extrusion process require a low MFI polymer. It is always on the viscosity for which process you are choosing the polymer, right? You always have to keep in mind, right? If it is a high polymer MFI polymer, this should go to a injection molding process. If it is a little bit low MFI polymer and low MFI polymer, it should go to some of the extrusion stretching process, like raffia extrusion and all.
Oh,
Understood?
yeah, understood, sir.
Okay, so that's it for today. And I think tomorrow we'll discuss whether it is there or not, or something like that. I don't think that tomorrow
Okay.
is lecture there. Today is the last lecture. What I have been informed, because they have told me that this is a single lecture, rheology, so you have to go for basic one, right?
Actually, two classes were left over in the during some Dasara time. That will be pending by 14th today and tomorrow. That was the actually message we have received earlier. The two classes it will be
Tomorrow's
happening.
class, I'll see whether I have time. If I have time, then I will take some, give you some examples of rheology, which polymer can go through which process and all.
Okay, okay, sir.
Yeah, because this is all our introductory slide, no? What is rheology and all, right?
Mm. Yes, sir. Yes, sir.
Okay, so that's it for today. Good night.
Thank you, sir. Good night.
Thank you, sir. Good night.